Welcome to True Projects. In this video, we are going to explain about the project that is construction of internet traffic monitoring model based on improved transformer algorithm. Before getting into the execution, first let us understand what is the project about. Internet has grown rapidly, transforming how we interact with the world, whether it is shopping online, watching videos, booking a hotel, or making a transaction. These services has made our lives very easier, but this openness also means that the internet is more vulnerable to exploitation. Hackers or malicious actors, they can take advantage of this to steal personal information, they can cause damage or disrupt digital services. Internet traffic. Internet traffic, it refers to the flow of data across the internet. Every time when you browse a website, send an email, watch a video, or use an app, you are generating internet traffic. It is basically the idea that moves back and forth between your website and the server that is being hosted. Here, this includes different kinds of information. It may be text, images, videos, or any other type of data that is being sent or received. Just like cars on road, internet traffic can vary in speed and volume. When there is more data being exchanged, it is like a busy highway with lot of cars. If there is a problem or malicious activity like hackers trying to break in, it is like someone causing a traffic jam or a crash. Monitoring internet traffic is crucial to ensure everything flows smoothly and securely. Preventing disruptions or security breaches without proper monitoring, it would be like driving without a rear view mirror. You wouldn't know if something is coming up behind you that cause harm. Proper monitoring helps to make sure everything works smoothly and securely. This allows us to enjoy the benefits of internet without compromising our safety for data. And thing is, while monitoring this internet traffic, it is super important, but the current systems that we have aren't perfect. One big issue is that they struggle when it comes to processing huge amount of data. As more people go online and use digital services, the amount of traffic grows and the existing systems can't always keep. Then there is a challenge of spotting the more sophisticated and varied kinds of attacks that hackers use. Sometimes the system get tricked and send false alarms, which makes it harder to trust them. Plus, these systems often have a hard time picking out the right patterns from all noisy and messy data they are given. So, it is really important to make sure our system stays safe. We need to improve these technologies where we need smarter, more efficient systems that can handle all the data, detect complex sets, and minimize errors. That way, we can stay ahead of the game and keep everything running smoothly without constantly worrying about new threats popping up. So, to overcome all these issues, this project proposes a technique called Improved Transformer, that is TransM. This system is designed to make monitoring internet traffic more effective. Here, it combines two advanced technologies. So, here, convolutional 2D layer, which is the deep learning layer, is incorporated. This helps the system to pull out most important features from the traffic data and then transformer attention with the transformer attention layer with self attention is incorporated, which really good at figuring out how different parts of the data are connected, allowing the system to recognize patterns in the traffic that might show something suspicious. And here, key part of the system is multi-receptive field fusion, that is MRFF algorithm. The purpose of this is to avoid losing any important information when the data is split into smaller chunks. So this MRFF makes sure that system can look at the data from different angles, improve its ability to detect any abnormal behavior in the internet traffic more accurately and efficiently. This way it is better at spotting issues and keeping everything running smoothly. And here the Trans-M model is tested using this NSL-KDD dataset, which is popular dataset for evaluating network security systems. To check how well the model performs, here we have incorporated several metrics that are precision, recall, FN score, confusion matrix, and ROC curves. These metrics gives us clear picture of how accurately the model can detect anomalies in internet traffic and how well it performs overall. The strength of this model comes from combining powerful convolutional operations with a transformer based self attention mechanism. This combination, so this combination it enhances, it focuses on the most important parts of the data, which leads to the better detection of abnormal behavior. Plus, by reducing structural losses during data processing, it becomes much more efficient and reliable, making it really effective for analyzing and monitoring internet traffic. So this is the proposed system of the project where we have incorporated improved transformer M. In that, we have combined convolutional 2D layers with the transformer attention layer with self-attention mechanism. Moving on to the extension part, to further improve the accuracy, here in this project, transformer M model is being combined with the bidirectional GRU. The cool thing is about this BiGRU is that it processes the data in both directions from left to right and right to left. This allows it to pick up the most important features and capture more details from the data, making it even better at analyzing complex patterns in internet traffic. So by combining both the methods, we get a system that is more accurate and can handle more sophisticated tasks. And on top of that, we have built front-end, user-friendly front-end using Flask framework. This makes it easy for users to test the system and interact with it. It also includes secure authentication so users can safely access the system and evaluate how well it performs. This extension not only boosts the prediction accuracy but also makes the system more reliable, accessible for users to try out and see how it works. And to implement this project, we have followed the steps mentioned in the flow of work. So first, we have imported all the required libraries and packages for this project. Then we move on to the data preparation part where we collect and load the NSL KDD dataset. The first step is to gather the dataset which contains label network traffic. And then we inspect the dataset structure. We examine the dataset to understand its features, that is data attributes, labels, whether there is traffic or it's a normal attack. And then comes mapping class labels. So here we convert all the class labels into simplified categories like normal and attack for easier analysis. Then comes the exploratory data analysis. Here we analyze the data set to identify patterns, trends, and relationship between different features. This helps us in understanding the data distribution and potential correlations. Coming to data pre-processing, here we convert categorical features. Here we transform non-numeric features into numerical values using label encoding for easier processing by machine learning models. Then we scale numerical features. We normalize the numerical features to ensure that all the variables are on similar scale, improving model performance. And then we randomize the data set to avoid any bias from the ordering of the data set. That is, we shuffle the data set. Then we remove irrelevant features. Here we identify and eliminate any features that do not contribute to the model's accuracy. Then comes the data splitting part. So we split the data into two subsets. One is training and testing. 80% of the data is assigned to training and remaining 20% is reserved for testing the model performance. Coming to model building, here we create machine learning model based on the selected algorithm, and here trans M model architecture will be designed here. It will be initiated. After that, it will be trained on the training set of the data set, and then it will be evaluated by using the performance metrics called accuracy, precision, recall, and etc. Then we compare those models through graphs. After comparison, we build the front end. We develop the front end using Flask framework, which enables the users to interact with the system. And it includes features like registration and login, supported by SQLite database for storing user information. And in the front end, users they will be able to give input as feature values, and that will be pre-processed at the back end, and it will be fed with the train model. Finally, train model will be giving us a prediction, and that will be displayed through the front end of the application. Moving on to the algorithms used. These are the algorithms which are used in this project. So first we have used LSTM RNN model, then BiLSTM. These two are used for comparison purpose. And this is the proposed model and this is the extension model, that is Trans MS combined with BiG RU. So this is about the algorithms used. To implement this project, we need basic requirements which are hardware and software. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview. Now let us execute. To execute, we are supposed to open the code folder which contains source code files. So let us open that. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? Open the dataset folder. This is the dataset that is used to train the models. Let's open it. It's being loaded. Just wait for a while. Until then, let's get into other things and know. So here, this is the test data in which we have test cases that we will be using in the front end to do the prediction. Dataset has been opened. So this is the data set that we have used in this project to train the models for detecting the attack. So these are the different features. Here you can observe, right? We have many features. So we will be using this data to train the models for detecting the network attack. So here we have class labels. Let's close this. And here in this, we will be having the test cases that we will be using on the front end. Let's get back. And in this model folder, we have the algorithm information that is stored in .h5 files, numpy files, and pickle files, and they will be loaded into the project code during execution. And this is a static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. So this is about the code folder. Now let us execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying it. Now open the command prompt. So it has been opened. Give the command cd, give the space, and paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port, unless configured differently. So this is the localhost and this is the port. Now we are supposed to copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to sign up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in and give your username and the password. So I'm giving my username and the password and click on login. We have logged in successfully and we are redirected to prediction page of the project. Here you can see a choose file button, right? We need to click on that for uploading the test case file. Click on choose file. This is the file that we will be uploading now. So select it, click on open. Before uploading it, let's see what do we have in that file. Get back to the code folder, open the data set and open the test data file. So these are the multiple test cases that we will be uploading now for predicting the attacks. So here we have multiple parameters. Let's see what are these parameters are. First one, we have the duration. It is the length of the connection in seconds. Then we have protocol type. It is the protocol used such as TCP, UDP or ICMP. And then we have service. That is the network service on the destination such as HTTP, FTP and SMTP. Coming to flag, it is the status of the connection indicating success or failure. For example, SF is successful connection. And then comes source bytes. These are the bytes sent from the source to the destination. And then we have DST bytes, which are bytes sent from the destination to the source. Then we have land. It is a binary indicator. Here, one if the source and the destination IP port are the same and zero otherwise. Then comes wrong fragment. It is the number of wrong fragments in a packet. Then we have urgent. It is the number of urgent packets in the connection. And then we have hot. It is the number of hot indicators such as failed login attempts. Then we have num failed logins. It is the count of failed login attempts in the session. Then we have login. It is the binary indicator, one if the user is successfully logged in, zero otherwise. Then comes number of compromised. These are the number of compromised conditions in the connection. So similarly, we have 40 inputs that we will be giving. 40 parameters. So for each case, we will be having all these parameters. Let's close this. Get back to the application and click on upload. So this given information, it will be pre-processed at the backend and then trained model will be giving us a prediction. So here we got the outcome, that is a prediction. So these are the different inputs that we have given to the application. So here you can see that we got prediction for every given test case. So for the first test case that we have given, this is the test case that we have given, and here we got the prediction that normal. It means there is no attack in the given data. That means there is no attack in the given provided information. Similarly, for the second case that we have given here, we got the prediction as normal. So here we got the prediction as normal. And for the third case, also we got the normal. And for the fourth case, here it has been predicted as attack. Similarly, for all the given test cases, we got the prediction. If there is attack, it is detecting attack. If there is no attack, the application is predicting it as normal. Now let's check with the graphs. Click on graph. So here the first graph which we have is a confusion matrix graph of the extension model, that is TransM combining with the BiGRU. And here is the ROC AUC curve graph of extension model. And this is the accuracy score comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are trained. And this is the precision score comparison graph. This is the recall score and this is the F1 score comparison graph. Accuracy, precision, recall and F1 score are the metrics used to evaluate the classification models. Now click on sign out. In this widget, by giving input to the application based on the given input and the parameters related to network attack, it will detect if there is attack. If there is no attack, it will predict it as normal. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.